Alright, so everybody's taking a moment to check their answers. Now, I made the first section optional, which means that I probably have 3 students all day long that'll do it. So, number 15. We can rewrite addition as multiplication. So this one's pretty cool, because at this point I can see a quadratic is forming. And then when I switch forms, I get 10 squared equals this. So yes, I have a nice little quadratic. So I set it equal to 0, and I solve, and I get this. So my factors are x plus 50 and x minus 2. My solutions, my possible solutions are negative 50 and positive 2. But in context of this problem, the negative 50 doesn't work, does it? It's an answer we got from solving, but it's not a true answer. We have an extraneous solution here, which we can eliminate, so the only answer is 2. Pretty cool, huh?
What is extraneous?
It's an answer that we get when we solve, but it's not applicable in the problem we're given. It's not. It's an extra answer that doesn't work.
Oh, like getting negative 3.
Now sometimes both of them work.
You're saying like if
But
you
sometimes,
the width,
like this log. If I plugged negative 50 back in, I get this statement: log base 10 of negative 50. Is that possible? It's not defined. So this equation is not defined for that solution. Therefore, it is not a solution. All right. Okay. A couple of people asked me about 23. We just need to write this with the equivalent base of 5. That was the easiest way to do that one, I do believe. Number 33, I had somebody come in this morning, and I solved this one totally different than I did here. Like this morning, I rewrote this 2 as log of 100. Because what is log of 100? 2. And then I rewrote that as division. And then I set these 2 parts equal to each other, cross multiplied and solved. So I got positive or negative 20, but obviously I eliminate the negative 20 because it's an extraneous solution again. But when I did this answer key, I moved this to the other side. Oh, nice. I like that too. And then this addition turns into multiplication. So we get this. And then we can switch forms. Let's see, Harry, if we did what you did right here, if we get our answer. Well, let's look. Harry was talking about doing this. Are these 2 equivalent?
Yeah.
Yeah? So then what Harry did was he pulled this 2 out in front. And then divided by the 2. Is this going to work for us? And then switch forms. So we get 20 equals x. Look at there, Harry.
Oh,
There you go, Harry.
Harry said we would not.
So yeah, sure you could do it that way. All right, 37. 37, they gave us these 2 equivalent logs, so we set them equal, we solve, we get this extra answer that doesn't work. Log of negative 3 is undefined, therefore x equals 4 is our only solution. Yes, Ben?
I have 2 questions. On 32.
32.
How do you divide x by x over, what is that, negative 100?
Okay, what I do whenever I have, that's a good question, whenever you have division of a fraction, I always rewrite it as multiplying by the reciprocal.
Okay.
So the numerator stays the same, we multiply by the reciprocal of the denominator. So this flips, and the x's cancel.
Good. And on 33, when you get down to 2 equals log x squared over 4.
Yeah?
How did you get 10 squared on the other side?
Okay, so this is logarithmic form,
Oh, you just rewrote it?
so I switched to exponential. All right, what else? Just go.
Show him how to move that.
Good luck. Teach him a lesson.
All right. Speaking of teaching a lesson, I think I will. All right, here we go. Our friend, base E, is back.
AC and I are not.
Oh, y'all are friends. It's a friendly relationship. Okay, so we're going to take those properties of logs that we've already learned and apply them to base E. It's really not a big deal. Okay, today I'm going to give you a monster review packet for a quiz. It's really large for a quiz. I know. You're gonna like it.
I mean, actually, they're not. When is the quiz?
Friday.
Quiz?
It's a major quiz. You know how sometimes we have like little quizzes that are like 30
So it's a
points,
quiz?
sometimes 40. This is a big quiz. Think about all we've done.
So it's a quest.
Most.
That's okay. I give you a review packet today. You're fine.
Wait, is it only like the logs and that's
When you say major review package, is it bigger than this
It was a
package?
packet packet.
I don't know what I'm doing.
It's 2 pages front and back and a third page. Alright, guys, what can we do with it for? I like it. Let's move it out front. Okay, now what?
You're right.
Divide by 4.
Then multiply by 7.
Because you're multiplying by 4.
We did. We're multiplying by 4.
So you can divide by
Okay,
4.
Jordan.
It's not equal to the other side. There's the
Math.
other side.
Well, 0 divided by 4 is still 0.
Somebody has an idea. I know you
Get
do.
rid of it.
Eric has an idea.
You write it.
But like, I don't understand how you can have log.
Okay, you've been talking the whole time. You can't ask questions.
Oh.
Is this equal to anything?
I know.
It is. It is.
Equal to 0?
What does that equal to?
2.
Did you say 1? Because I'm going to be excited if you said 1.
Oh, because it's E and then LN is
Oh,
E.
because it's ln means log base E. So what power do we raise E to get E?
Yes.
1. So what can we sub in right here?
4. It equals 4.
Alright, and if we think about it from last week, if the base and this match, that's a happy day.
It equals 0.
It does. Okay, what do you think about number 2?
X minus Y.
X minus Y, because we pulled that out in front. We know that the value of ln of E is 1, because ln means log base E.
So it does absolutely nothing?
No.
Oh, it does a lot.
But it just one.
It
Just
It evaluates the expression.
Number, you have to multiply by which is
Okay, what do you think the answer is?
Negative 2x.
Bingo. But do we understand why?
Yes.
Okay, because the why will stick in our memory. The memorizing, it goes away so quickly it's not even funny. So if you know that you bring this out in front and then you can think about this in terms of what does natural log mean, it means log base E, then you can work your way through it even if your memory fails you. Alright, so let's look at some that are ugly in a different way. What do you think the answer is?
too confusing.
This
So
way.
it's 2 to the second, right? Log
Wait, no,
E.
2.7 to the.
Alright, so we're not sure. So, since we don't know, let's set this equal to something.
2.
Let's say
2.
equals an answer. 2 is correct.
Rewrite
Figured it out.
So if we switch forms, it becomes log base E of an answer equals the exponent. Well, we would never write log base E.
It's ln.
That's ln.
Like base.
So what is the only way this can be true is if this equals this, so my answer is 2. When the base matches the base, it ends up being this. This is why, though.
What? The day is stellar.
Stellar?
The joke.
Oh, I love when they make that left turn.
Alright, what is the answer to number 5? Y. What is the answer to number 6?
2.
8.
2.
Okay, why is it 8?
Because the 3's out in front.
Very good. You guys have it. I don't even need to spend all this time going over it. But I am. Because maybe somebody in the room didn't have it. And now they get it. Because 2 to the third is 8.
Oh, I kept doing 6.
It's crazy.
Mathematical happiness right here.
Wait,
What?
I'm sorry.
I can.
Wait, Doug, is that all good? What is the purpose of it?
Keeps his neck warm.
And my ears. If I,
Yes, ma'am.
it's called fashion.
Sure. All right, are we good?
Yes.
Okay. You know what? I don't even want to teach this, so you just try it.
Okay. Wow.
I don't need to teach this. You know what to do. You can do this.
You can just see your eyes, so it's really shady, Doug.
I'm doing a lot of research on flipped classroom right now, and I'm thinking
That's so hard.
What
I'm
is
thinking
flip
it would be a good choice for this unit.
Miss Trimmer really ruined that for me.
Yeah,
But what's
Mr.
flip
Murray.
classroom?
But we did flipped classroom last semester.
That was fun.
Yeah.
What?
We did.
We did it for the conic unit. Remember at night you watch videos and in class we did.
Oh yeah, Professor Berger.
Oh, I don't like the burger.
Yeah.
They can change the back to Wikipedia page after I'm done. with it.
Well, it was fine
I didn't
there,
watch
but
someone's
Miss
ads in the
Shermer
background.
had a terrible system of that.
All right. Well,
My clothes.
Yeah, I can.
That really sucks because
Yeah, actually.
Are we just always gonna leave him for him to eat?
For once.
I really like exact. Now exact doesn't make a whole lot of sense in terms of a word problem, but we will leave our answers in exact form until we just can't.
Why does your ex have a little foot?
Because it wants
We already had a
to.
conversation about her right. It was a while ago.
Let the ex do its thing.
All right. Now this is why we bothered in the first place. All right, guys. What power do we raise 2 to get 5?
Something.
Something.
Not one we know.
And it's not one we know. But now we have lots of ways to solve for exponents. The first one is just to switch forms. So our first exact answer would be log base 2 of 5. That's an exact answer. Okay? But it doesn't help us get to a decimal that makes sense to our brain. But the next thing I do will. I got 2 ways to do it. Put a big or in between. All right, so what do we do to solve for logarithms? I mean, to solve for exponents.
You switch the X and Y.
We use logarithms, right?
Yeah.
Yeah, that's an inverse. All right, so we're going to use a logarithm to solve for an exponent. So, if I take the log of this side, to keep the equation balanced, wouldn't I need to take the log of that side?
Yes.
Okay, and then what could I do with this exponent? It can come out in front. It sure can. Okay, so to solve for x, wouldn't I just divide by log of 2?
So X is 5 over
So it's 5 over 2.
No, it's log of 5 over log of 2.
Wait, what was
It's
it?
not the same as 5 over 2.
They can't cancel each other out.
They cannot.
Oh.
Because log of 5 is asking us what power do I raise 10 to get 5. All right. Could I have done this?
Yes.
Yes, I could.
Obviously.
You are correct.
That man had a very astute guess.
All right. And for those of you that are slightly lazy, this is probably your method of choice. It has one less letter on both sides.
That's sweet.
I'd like the number 10, but then 2.7, so then.
Is that just the same
Hey, that's
thing?
6 letters.
I don't know. Let's see. Look what we did, though. Isn't there a log button on our calculator?
Yeah.
Isn't it base 10?
Yes.
Is there also a natural log button on our calculator?
Yes.
Oh, look how beautiful this is. This is an exact answer. This is an exact answer, but either exact answer will lead us to the approximate answer. What is it?
I got different ones.
1.22036023.
I got different answers.
We have a problem if you got different answers. Should get
Where's the Ellen?
2.322.
It's right below the log button.
That's a weird
Oh, wait.
parentheses.
Just kidding.
Calculator says that.
Why wouldn't it be long of subscription too?
It is the same thing. It's 2.3. Yeah.
Is the next answer 3/2?
I forgot to change
Wait,
parentheses.
yes.
Is the exact answer what?
Is the next answer 3/2?
It's not reading.
Apparently it makes a difference.
Alright, so now if you take 2, it's not going to be exact because this is approximate, but if we take 2 and raise it to the 2.322, do we get really close to 5?
I'd say no.
Perhaps.
Oh.
You've got a calculator punched in.
Yes.
Yes, it's close. It's not exact, but it's close. So do you see how this is an exact answer. This is an exact answer. This is an approximate answer.
Because you can't get it down.
Okay? Now, we know how to solve this problem. We don't even need logarithms. I wouldn't pick up my calculator for anything if I saw this problem. I would go straight here. And I'd get x equals 3/2 or 1.5.
That's
What about next?
Okay? But
I know.
what if I took the log or natural log of both sides?
He gets to the same answer.
It does. And it even gets to it a very interesting way. I'm going to show you something. You're going to like okay, you might not like it.
You're gonna like it.
Okay, if we punch in log of 8 divided by log of 4, do we get 1.5? Let me show you why. Could I rewrite 8 as 2 to the 3rd?
Yes.
Could I rewrite 4 as 2 squared?
Yes.
Then could I bring the 3 out in front?
Yes.
And can I bring the 2 out in front?
Yes.
Now, are these identical?
Yes.
Yes, and what's my answer?
No. I thought you could cross those out.
Okay,
But you can now because they're
identical.
identical now.
They're identical.
The exponents.
Log of 2 and log of 2 are equal. So yes, I can. Log of 5 and log of 2 are not.
So you were very worried.
Yeah, we can't cancel those. But we can this.
I was thinking like they have the same base, so why can't they cancel each other out?
Alright, so whether we stop here and punch in our calculator and get 1.5, or we go here we get 1.5, or we use the properties of logs and get 1.5.
1.5.
Yes, that is the answer. 3/2 or 1.5. And do you see how it kind of, in a nice way, gives us lots of proof that this is true? Yes, sir.
Is it okay if I solved it like a different way? Like with x, I took the square root of 4 and then put that on the bottom. So you have 2 to the square root of 1/2, and then what you get to get 8. Like you cube it.
I can't follow you at all, but if you'll
Okay,
write that
well,
down and
it's
show it to me, I'll talk to
It's
you about
easier
it.
for me, but I don't know if I can do that every time.
Alright, what this actually develops is what's called the change of base formula. It's not something I want you to learn at all.
I'm thinking of base base.
I don't want you to memorize a formula that has no meaning. But what we end up doing, we end up converting to base 10, or we end up converting to base E.
Are we gonna be tested on this?
And so these are not this formula, but
Yeah, that's
can
right.
you solve? Yes. And so right here, when we're converting both sides to the same base, that's what this change of base formula tells us. To find log base B of a number, we can take log base A, and for us that's either going to be base 10 or base E, because those are the two that our calculator manipulates for us. Of the answer part divided by the base, and you do not need to memorize this formula. It is way easier to solve the problem. So don't worry about memorizing that formula. But if anybody ever talks to you about the change of base formula for logarithms, that's what it is. the log of the answer part divided by the log of the base. Okay, so you pick log, natural log. Let's see what you can do with this one. Give me the exact and the decimal approximation to 3 decimal places, please. Thousandths.
Let's see if I can try to explain this. So you start off, you just ignore the square root sign for now. You start out with 4x equals 8, and there's a square of 4, and x changes to 1/2 of my answer. It doesn't like change this when you're still doing the equation, but in the answer you know it's going to be over 2. And then because square rooting it puts a 2 on the bottom, so you have something equals 8.
Yeah, you raised both sides. Yep. Okay. So if you took the log of both sides, it ended up looking like this. Log of 7 to the x equals log of 20. So the x came out in front. So we get log of 7 equals log of 20. So x equals log of 20 over log of 7. That's an exact answer. Another exact answer would happen if we took the natural log of both sides. So you could have done it this way. And the exact same process occurs, and we get x equals natural log of 20 over natural log of 7. Now, these are my exact answers. The decimal approximation, what did you guys get for the decimal approximation?
1.549. Oh yeah, we're on there.
Approximately. Okay, so now remember when we did all those crazy word problems and we shifted them all down to the x-axis and we looked for zeros and it was ugly and we had to figure out the window on our calculator and we didn't like it. Here comes the easy way. This is what Makira's dad kept saying. You just use logs. And he's right.
It was a really intense conversation.
It was awesome. Okay, so let's say we have a city that has a population of 143,000 people. That population is decreasing at 4% per year. When will the population hit 100,000 people? So if this is how I model it, obviously I put this in terms of thousands. Do you see this 0.96? Represents that decay. All right. So we want to know when it'll hit 100,000. So I'll just put in 100. Okay. First thing we have to do is get it in exponential form. And so we have this extra right here. This is not part of exponential form. Remember, exponential form is just a base raised to an exponent equals an answer. So this 143 is multiplied times this. So what would we do? Divide it. So we're going to divide both sides by 143. Now, if it divides nice and pretty on the side and it gives you a terminating decimal, go for it. If it doesn't, leave it. We don't want to approximate here and then compound that error. So we're never going to round until the very last step. So we get 100 over 143 equals 0.96t. Okay, how do we solve for an exponent?
Logs.
Take the log of both sides. Okay, so we can do logarithm or we can do natural log. Either way, at both sides. So if I did natural log, I get natural log of 100 over 143. And here that t can come out in front. and now I have natural log of 0.96. And so to solve for t, I would divide both sides by natural log 0.96. Now this would be my exact answer, which in terms of a word problem is meaningless. So let's go ahead and punch this in and round to the nearest thousandth place. And this is years, 8.762 years. Is about how long it would take this population of this poor little city to reduce by 43,000 people.
Now, what year would that be?
It depends on what year we started.
I mean, like the month.
You would just take this 0.762 and multiply times 12, and you can figure out the month.
I guess that's about the ninth.
Huh?
Is that gonna guess that's about the ninth?
Yeah,
Yeah,
that's right.
yeah.
14.
Wait, why would you do 0.96 if it's reducing by points like September or 0.94?
Because right here, if we do 1.00 minus 0.04, that gives us our multiplier.
Oh yeah, like
Okay, guys, this is much nicer than doing all that ugly shifting on our graph. And, yeah, we don't have to worry about a window at all.
Pretty nice.
Windows are no longer an issue. Okay, we actually have done one like this too, and it was really ugly on the calculator because remember when I put up Desmos, we had to kind of really zoom in to find the K? Because K is very small.
that Doug kept making us zoom in further.
Yes, that was that one. Thank you, Doug. Alright, so this is
Now we'll always remember it.
that's true. This is out of our textbook on page 301. It's called a paleontology application. The example that they give us says a paleontologist uncovers a fossil of a saber-toothed cat in California. He analyzed the fossil and concludes that the specimen contains 15% of its original carbon-14. Well, carbon-14 has a half-life of 5,730 years. So we're going to use that carbon-14 dating to determine the age of the fossil. Alright, so first of all, let's deal with this part and see if we can find that decay rate, that constant right here. So if we know that whatever we started with, 100%, if we know its half-life, then half would be left, right? And we know the half-life is 5,730 years. So we can solve for K. This is going to be so pretty. 1/2 is 0.5. And we're solving for K. So we're solving for an exponent. What do we use when we solve for an exponent? Log. And particularly in this case, I'm going to use natural log. Why am I choosing? And I'm only going to use it because it's spacey. Much easier that way. And so when I go to rewrite this, and this exponent comes out in front, it becomes multiplication, then a beautiful thing happens. This is just ln of e right here. And what do we know ln of e is equivalent to? 1. It's like multiplying by 1. Multiplicative identity, it's not changing. So to solve for k, we would just divide by that negative 5,730. And so we're going to leave k in its exact form right now. Because it is such a small number, we're just going to leave it as ln of 0.5. And you could punch it in your calculator and see what it is. It's tiny. Yeah. Now, if we were to round here, my movie is really misbehaving. There we go. That was supposed to be a 0 right there, guys. Okay, so this is my exact value for k. If I were to go ahead and round this, and then I plug that back in and I use it for something else, once again, I'm taking that error and I'm making that error greater. So I don't want to do that. I want to use this exact value. Now I'm going to answer the question. Because the question asks, when is 15% of the original left? So now, instead of equal to 1/2, I'm going to say 100% is down to 15%. And I know K. I know K is this. But this is supposed to be the opposite of K. Well, K is negative here. So if I take the opposite of negative, I get a positive. So I'm just going to write this as ln of 0.5 over 5,730 times t. And I'm solving for t. And I'm thinking, I know I need to take a log. But in this case, because I have a base of e here, I'm going natural log. So natural log of 0.15. And this 1 doesn't really matter. So I get the natural log of e to the ln of 0.5 over 5,730 t.
Would it be negative?
It was a negative k. So when I do the opposite of a negative, it becomes positive. All right, so this comes out in front. And then I'm left with ln of e. And eventually I wouldn't even write that anymore because I know ln of e is 1. But right now I am, because it's our first day. So I wouldn't even write this. Go. And so I've got t times this, and it's a fraction. So I'm going to multiply by that reciprocal. The reciprocal of this is 5,730 over ln of 0.5. So over here I'm going to multiply by 5,730 over ln of 0.5. And that's what I'm going to type in my calculator. This right here.
It always seems so much easier.
I forgot what we were trying to find.
How long it takes till there is 0.15% of the saber-toothed cat. How long?
Oh yeah, half-lives.
Yeah, we dealt with half-life.
Indiana Jones didn't teach me this part of paleontology.
So we have seen it quite good.
Predicted it.
Did you get approximately 5,683 years?
Yes.
Yeah, 50.
I got what you got.
Yep.
Did you close your parentheses right here?
Nope.
That might be it.
I got 8.3.
It should be 15,682.81285.
Could you show what that like write what that would be? What would you plug it into the calculator?
5,730. The divide by button. The ln button. 0.5. It opens your parentheses. You've got to close them.
Oh, I see what I did.
Then times button. And then ln of 0.15. It opened them. You don't have to close them because it's the last thing you do. And you hit enter.
That's what I got.
That's the exact keystrokes.
Wait, so how did you change ln.5 over 5,730 to 5,730 over ln.5?
Because I had this fraction. So to solve for t, I had to multiply by the reciprocal.
I still keep the other.
Ow!
What did you
I
do?
think I have carpal tunnel.
I have watched you take notes, and there's no way you got carpal tunnel from taking notes.
This is
Oh, did we get our review guys?